Okay.
Yeah.
First question of the day is, I would like you to find the sine of 30 degrees plus 45 degrees. So we're going to talk our way through this a little bit. What would be your logical thought? Sine of 75, but do you know the sine of 75 degrees?
Sine of 1/2.
You don't know the sine of 75
One
degrees.
half.
Now, I'm going to ask you, and you will not need your calculator today.
The chart.
I'm going to ask you, so will the book, to give answers, give exact values.
The chart.
Now, what does exact values mean?
The chart.
It means exact values, yes. It means fractions. It means
The chart.
the chart. It means radicals. What does it not mean? Decimals or, what were you reaching for? Calculators. Exact values means no calculators. All right? So if I'm asking you here for the sine of 75 degrees, okay, we're not asking you to punch it into your calculator. So what would be the logical thought, what would be your logical thought to get this started?
Go to the chart.
Okay, so the sine of 30, and we're going to do this over here. Don't write this down. So the logical thought is the sine of 30 degrees plus the sine of 45 degrees, correct? That's what you're saying? All right, what's the sine of 30 degrees? 1/2. What's the sine of 45 degrees? Square root of 2 over 2. So if we add those together, we would get 1 plus square root of 2 over 2. This is the one moment today that I'm going to ask you to use a calculator, and I only need one person to do it. Can you tell me what 1 plus the square root of 2 over 2 is equal to?
1.207.
It's approximately equal to 1.207. How do you feel about that answer?
No.
Now you know it's wrong because I said don't
No.
write it down, so I get that. What's another reason it's wrong?
It's over 1.
Because it can't be over 1. Why can't it be over 1? Because sine can never be greater than 1, correct? So, therefore, would it be fair to say that the sine of 75 degrees cannot possibly be the sine of 30 degrees plus the sine of 45 degrees? Okay. And it will never be anything like that. It'll never work that way. Trig functions are not distributable.
Distributable? That's a
I
word.
think I just made it up.
No, that sounds
You cannot
horrible.
distribute trig functions. Okay?
But that is equal to the sine of 75.
This is equal to the sine of 75 degrees. Absolutely. So, what we need is a formula. We don't need a calculator. What we need is a formula. And the formula, coincidentally, happens to be
Written
over
on the
my
board?
left shoulder. I just got lazy and didn't feel like writing it all over again. So, here are the formulas that you are going to need for this section and for the rest of the chapter. Okay? We have formula number 1, the sine of alpha plus beta. Okay? And the sine of alpha plus beta is equal to the sine of alpha times the cosine of beta plus the cosine of alpha times the sine of beta. And yes, that whole thing is necessary. Now, what happens if we are subtracting? Instead of alpha plus beta, we did alpha minus beta. Well, the book gives you a whole new formula. Here is the formula if you add sine of alpha plus beta. Here is the formula if you subtract alpha minus beta. You know that I'm not a big memorizing person, so I've got to find ways around it. So here is the very simple one. If it happens to be sine of alpha minus beta, then we just change that sign in the middle to a minus. That's all. And everything else is the same. So sine of alpha minus beta would be sine of alpha cosine of beta minus cosine of alpha sine of beta. I'm going to get to it all.
Same time.
Okay there?
Yeah.
After sine, obviously, will come cosine. And so the cosine formula is a little bit different. Same basic setup. The cosine of alpha plus beta is equal to the cosine of alpha cosine of beta minus the sine of alpha sine of beta. You'll notice a couple of things. First of all, in this case, cosine cosine is together and sine sine is together. Whereas in the sine one, it was sine cosine and cosine sine. And the other one is, in the sine formula, if it was alpha plus beta, and this was a plus sign in between, and if this was a minus, alpha minus beta, it was a minus sign in between. In the cosine one, it flip-flops. If this is an addition here, it's a minus in between, and then as you can see down below, the opposite also holds true. Okay? And then we have my least favorite one, the tangent one, which says that tangent of alpha plus beta is equal to tangent of alpha plus tangent of beta over 1 minus tangent of alpha times tangent of beta. If that changes to a subtraction, alpha minus beta, then the top becomes subtraction and the bottom becomes addition. Now all of those are provable if you'd like to ever sit down and try to prove them.
No thanks.
I figured that would be the thought, and that's okay. You will need to know these, so get to work remembering them. And we're going to go through some stuff now to show you how it's going to play out. Okay? So let's go back to the original question. What's the sine of 30 degrees plus 45 degrees? So in this case, what is alpha?
30.
And what is beta? 45. So let's jot down the formula. Tell me what to write. Sine of 30 degrees times the cosine of 45 degrees plus cosine of 30 degrees sine of 45 degrees. Do not try to skip that step. It almost never works. And if you know me, you know I like the shortcuts. Write down the first step. Write this down. Okay? All right, what do we deal with now? Oh, we deal with the chart. Let's look at what we have here. We basically have 4 things right off the chart. Huh. You think that's going to happen a lot in this section?
Yes.
Yes. So for those of you that over the last few weeks have the chart has kind of slipped a little bit. Not over the next week and a half, you'd better get it back. Okay? Because we're going to do, I would say, at least 20 chart questions a day. Probably more on most days. Okay? So you got to know it. So here we go. Sine of 30 degrees. 1 half. Cosine of 45 degrees. Square root of 2 over 2. Plus cosine of 30 degrees. Square root of 3 over 2. Sine of 45 degrees. Square root of 2 over 2. By the way, God bless you. Bless you.
Thank you.
Do you remember back at the beginning when we were coming up with the chart and where those angles or where those values were coming from and stuff like that? And I said we're going to get to the point pretty quickly where you're not going to be able to go, okay, so the sine of 60 degrees. So if I go a 30, 60, 90 triangle, which is 1, 2, and square root of 3, and then the 1 goes here and the 3 goes there. And so the sine of 60 degrees is going to be opposite over hypotenuse, square root of 3 over 2. Remember how we started that and we said you're not going to be able to do that at some point? With me now? Okay, yeah, you just have to know. So, and we can't draw the unit circle every time and all that stuff. You just have to know what the sine of 30 is. All right, what now? Multiply. What's 1/2 times square root of 2 over 2? Square root of 2 over 4?
Mm-hmm.
You sure? Okay. How do you multiply fractions? Multiply straight across. Multiply the tops, multiply the bottoms. Yep. Just got to remind you, just got to make you think and make sure we're still all on the same page. Because this is where silly mistakes come in, by the way, when test time comes. Yeah. What's the square root of 3 over 2 times the square root of 2 over 2?
Square root of 6 over 4 and square root of 2 over 4.
So the question that I'm hearing, basically, because of the different answers, is are we allowed to multiply the square root of 3 times the square root of 2? That seems to be the question. So, you know me, I'm always going to answer your question with a question. How would we deal with the square root of 12? What would we do?
Square root of 4 times.
We'd say square root of 4 times square root of 3. So the square root of 4 times the square root of 3 is
2 over 3.
the square root of 12. Can we multiply radicals?
Yes.
Yes, we can. So therefore, what is the square root of 3 over 2 times the square root of 2 over 2?
Square root of 6 over 4.
Square root of 6 over 4. Good. All right, so now we can combine them into one fraction.
Square root of 2 plus square root of 6.
So what is the square root of 2 plus the square root of 6?
Square root of 2 plus the square root of 6.
It is the square root of 2 plus the square root of 6. That would be our answer. That's the answer. Is that an exact value? Yes, it is. Question number 2. I think there's a pink one all day. I would like you to find the cosine of 70 degrees times the cosine of 40 degrees plus the sine of 70 degrees times the sine of 40 degrees.
That's just the formula.
Well,
That may be the first time I ever heard you say that.
He said that was.
but you also sine of like 7, which is like splits with these.
We just did that.
Go ahead, you speak. It's just the other way around. Do you know the cosine of 70 degrees? No, neither do I. But according to Jake, you don't need to know the cosine of 70 degrees. Because what did we give you right here?
Oh, this is the community.
Formula.
We gave you this. Right, we gave you this. And so, wait, what is this the formula for?
The subtraction of cosine.
So this is the cosine
The
of
subtraction.
alpha
Minus.
minus beta. What's alpha?
70.
70 degrees. Minus, you said?
40.
What's beta?
40 degrees.
40 degrees. Which really means, what are we asking you for?
30.
We're asking you for the cosine of 30 degrees, which is?
Square root of 3 over 2.
I like that one too. I like those. I like those. But you obviously have to be able to recognize it as the formula. And if you don't recognize it as the formula, you're going to start cursing at me because you're going to be saying things like, how are we supposed to know what the cosine of 70 degrees is? How are we supposed to know what the cosine of 40 degrees is? We don't know that. So, you got to recognize it. All right, how are we doing? All right. Okay. Let's see, what should I do then?
Will you be all right after this? I hope my thing's still recording. That'd be nice.
Maybe we should.
What? Oh, no. I heard something
Should we make it more
way
difficult?
worse.
Okay,
No. 3 letters.
let's find the
Snuck
tangent
down.
of pi over 12.
Different consonant first. C.
K.
I mean,
Oh.
yeah.
Tangent of something degrees.
Tangent of pi over 12.
That's a.
What are the first thoughts?
How about no?
Convert it to degrees.
Degrees, go to degrees. Because pi over 12 is not one of our standard angles, correct? What are our standard angles? Pi over 6, pi over 4, pi over 3. Those are our standard angles. Pi over 2, not pi over 12.
2 pi.
So you want to change it to degrees? All right, what is it?
15.
It's 15 degrees. How'd you get that?
180 over 20.
180 divided by 12? Okay, cool. Another way, if this helps, it's half of pi over 6. Pi over 6 is 30 degrees, and half of that is 15. So we're good. And so luckily we know what the tangent of 15 degrees is. It is...
Nah.
No, we don't know. Not on the chart. Doggone it. All right, so we better come up with a way to get 15 degrees. How can we get 15 degrees?
45 minus 30.
45 degrees
Minus 30.
minus 30 degrees. Okay. So again, we're still using chart angles, right? So now, since we have the tangent of 45 degrees minus 30 degrees, what can we do? We use the formula. So, go. Tangent of 45 degrees minus tangent of 30 degrees. Remember, since this is being subtracted, the top is being subtracted. Over plus tangent of 45 degrees times the tangent of 30 degrees. What time is it?
Short time.
Chart time. Here we go. Tangent of 45 degrees. 1 minus tangent of 30 degrees.
Square root of 3 over 3.
Square root of 3 over 3. Over 1 plus tangent of 45 degrees. 1 tangent of 30 degrees.
Square root of 3 over 3.
We just did it, so you should know it. It's right there. It's also there. Yep, there we go. All right, so the top is 1 minus square root of 3 over 3. The bottom is 1 plus 1 times. Yeah, so we can get rid of the 1 times here. All right. It's a mess. What do you not like the most? Wow, you know, you guys, that's the first people all day that have said that. And I agree with you wholeheartedly. Well, what they're saying radical in the denominator. Other classes said radical in the denominator, and I said, to me, that's a secondary issue. Complex fractions first. Wow, you got the name of it too? Dang, you guys are good.
I don't like radical.
Yeah, well, we'll get to that. So, complex fraction. How do we deal with complex fraction? Not by the reciprocal.
The conjugate.
By the conjugate. Not by the conjugate. Multiplying the conjugate will work with the radical in the denominator thing. But it will not help with the complex fraction thing. Multiply by what? Not reciprocal, not conjugate. One of the things that you have to remember here is that you have to do something that is mathematically okay. It's mathematically legit.
Canceling.
So, least common denominator? What are you going to do with the least common denominator? I like least common denominator here. What are we going to do with the least common denominator? Multiply the top and bottom by the LCD. This goes back. We did complex fractions way, way back ago. Never heard that phrase in my life, but I just made it up.
Oh, wait, back.
Way back ago.
My favorite time period.
But as you know with math, it's just stuff that we have to keep using. We have to remember it and we got to keep using it. So what is the LCD here?
3.
3. There are two fractions, right? And the LCD of those two fractions is 3. So let's multiply everything by 3. Which basically means we're multiplying the top and the bottom by 3. And multiplying the top and the bottom by 3 is,
All right.
it's okay, right?
Yeah.
So, what happens when we do that?
The ones turn into 3.
What do we do now?
The square is just
I don't want to multiply first. I would like to cancel first. What can we cancel?
the denominator.
The 3's, the denominators. That's the whole purpose of multiplying. So the 3's go and the 3's go. Oh. It's coming back to me now. So we do that. What do we have?
3 minus the square root of 3 plus
3 minus square root of 3 over
3 plus square
3
root of
plus root 3. What do we no longer have?
3.
A
Complex
complex fraction. We have taken care of the complex fraction. Life is good. We can move on.
No. Radical
Next issue.
denominator.
Radical in the denominator. We need to rationalize. How do we rationalize this?
Conjugate.
Multiply by the conjugate. Remember, it's a binomial. Say it, come on.
No, it's okay.
I'm sure there are 33. Well, okay, there are only 25 people in the class. Okay.
Yeah, yeah.
Okay. The conjugate is the same two terms, but we change the sign. So the conjugate here that we're going to multiply by is
3 minus 3 square root of 3.
Huh?
3 minus square root of
3 minus root 3. If we were taking the opposite, then we'd have to change both signs. So the opposite of 3 plus root 3 would be negative 3 minus root 3. And then the reciprocal would have to be like 1 over that or something like that. So when we're trying to rationalize the denominator, and it's a binomial, we will multiply by the conjugate. The reason we'll multiply by the conjugate, anybody remember?
square root.
Why does it work that way?
Because it makes it the square root of 3 squared.
True. But how would we multiply these?
Okay, so if you foil, when it cancels.
We foil.
Yeah, and it'll cancel.
But when we foil
You only get
conjugates,
You get this first and last.
right, the oi, remember the outside and the inside, will always cancel. And that's the whole purpose of multiplying by the conjugate. So we multiply by the conjugate, the outside and the inside. When we foil here, we'd have minus 3, we'd have negative 3 root 3. And when we do the inside, we have positive 3 root 3. And the negative 3 root 3 and the positive 3 root 3 would cancel out. And so, when we foil this, all the outside and the inside would cancel, so all we'd have is first and last. So we multiply the first, what do we get? 9. When we multiply the last, what do we get?
3.
And so you'll notice that in the denominator, we know, that is 6. We no longer have a radical. And that's why we do that. Numerator.
Square double square.
Square double square. Straight foil, however you want to do it is good. Give me some numbers. 9 minus
Root 3
6 root 3
plus 3.
plus 3. Remember that we are foiling this. So first gives us the 9. Outside gives us a minus 3 root 3. Inside gives us a minus 3 root 3. So we have minus 3 root 3 and minus 3 root 3, which gives us minus 6 root 3. And then we have the last, which gives us the plus 3.
I'll be out there.
Yeah? Foil the top, foiling with radicals. Takes a minute. Yes? We okay with that? All right, now what? What do we get? Yep, help me.
12.
12
Minus 6 and
minus 6 root 3
over 6.
over 6.
Can we,
Can we?
Yes.
Good question.
Yes, you can.
Yes, we can. No, we can't.
Yes, you can.
I've heard both answers.
Yes.
I understand both answers. If we can cancel, what can we cancel?
12 and 6.
Everything.
Has to be everything.
Everything right. So, yes.
So if the question is, can we cancel the 6s?
Yes.
The answer is no.
Oh.
Unless we can also cancel what's here.
Yeah.
So everybody was right. All you guys, everybody said something correct. How was it? Boring. Did you do anything? Yeah. Then thank you. Plus, we all look good now. So we can cancel, but we have to cancel the 6, and the 12. Does that make sense? We remember we can't cancel things that are being added and subtracted unless we cancel everything, which gives us,
2 minus root 3.
and that's our answer. What was the toughest part to that problem?
Yeah, probably foiling.
Simplifying. I mean, to me, remember when this problem started, we were talking about what's pi over 12?
Yeah.
That seemed like 20 minutes ago. But turning it into 15 degrees and saying 15 degrees was 45 degrees minus 30 degrees and putting it in the formula, that wasn't that bad, was it? The biggest pain was complex fraction, conjugate, simplifying, all that stuff. That was the biggest pain. Can I show you something?
Was there a shortcut?
Is there another way we could have gotten 15 degrees? Is there another way we could have gotten 15 degrees?
60 minus 45.
Could we have done 60 degrees minus 45 degrees? I mean, seems basically the same thing. I'm going to do it for you real fast, okay? So we're doing tangent of 60 degrees minus 45 degrees. Same basic thing, we just took two different angles. Instead of 45 minus 30, we did 60 minus 45. No big deal, right? So that gives us tangent of 60, which is square root of 3, minus tangent of 45 is 1. I should have written that out first. I'm going to write it out first, because I'm telling you guys to write it out first, so I should do it. Over 1 plus tangent of 60 degrees, tangent of 45 degrees. Fair? Tangent of 60 degrees is square root of 3, tangent of 45 degrees is 1. Over 1 plus tangent of 60 degrees, square root of 3, times tangent of 45 degrees, which is 1. Don't need the times 1, right? So we got that. What do we not have? Don't have a complex fraction. Now the rest of the problem is pretty much the same. What would we have to do here? Multiply by the conjugate, which is 1 minus root 3. So 1 minus root 3 on top and bottom. Top, we have to FOIL. So first, outside becomes minus 3, please. Inside becomes minus 1. Last becomes plus root 3. Bottom becomes square the first minus square the second. So on the top I see negative 4 plus 2 root 3. You see that? And on the bottom I see negative 2. And can we cancel the negative 2's? So that would give us a positive 2 and a minus root 3, which happens to be exactly what we got there. Okay. Now, it wasn't a lot easier,
It just said less than that.
but we didn't have to do the complex fraction part. What caused us, what created the complex fraction? Tangent of 30 degrees. So if you have an option about using tangent of 30 degrees or tangent of 60 degrees, my suggestion would be choose 60 degrees because less fractions. Make sense? Cool. Questions? For the next problem that we're going to do, I need space, so I'm going to have to go back to this area. So finish up copying. Let me know when we're done. It was so cold in the computer lab during 5th hour that I actually needed a jacket in the middle of April.
It's almost summer, and I'm still bringing a jacket to school because
That's because some of the rooms, they're
they're freezing. My history teacher makes it like negative 20 million
It's not,
degrees.
we have no control over our room temperatures.
Oh no, he goes, I change it. He's like, I turn it down on the
He's messing
thermostat.
with you.
I'm like, how?
Anybody still need this? Okay. All right. So my next question is this. Please find the exact value of cosine of alpha minus beta if the cosine of alpha is 1/3. It is 1/3. And the cosine of beta is negative 1/4. And the terminal side of alpha lies in quadrant 4, and the terminal side of beta lies in quadrant 2. Okay, go to work.
About? Is it worth pausing?
Thoughts? Huh? Remember, we're not using calculators at all on this stuff. Huh? Don't you just use the formula? Would that be a logical move here?
Yeah.
It would be a totally logical move here, considering what did we just learn about 3 minutes ago? We just learned the formulas. So it certainly makes sense for us to use
The formula.
formulas.